Hello JupyterCon, my name is Tom, also known as Data Engineer 1, and today I'm going to be showing you guys how you can use Kedro and Jupyter Notebooks. Kedro is a framework built by Quantum Black geared towards data scientists and data engineers to help them write better data pipelines. Oftentimes what happens is a lot of data sciencing and data engineering work is collated inside of notebooks, which are very useful for those experimentation and iterations, but can fall away when you want to try to reuse that pipeline, you want to try to move that pipeline, or you want to try to understand that pipeline a month down the line. In that process of finding out how best to collaborate between data engineers and data scientists, Kedro was born. Kedro is a scalable, modular pipeline building framework. In today's video, we're just going to be talking about a single Jupyter notebook and turn it into a Kedro pipeline. This notebook in particular comes from the British Natural History Museum. We're going to be taking the APIs that are available and downloading the data and then creating the transformation nodes that we would like to reuse inside of Kedro. Now we can go ahead and get started by cloning example. Now that that's done, let's go ahead and install Kedro. Now to get Kedro, you just type in pip install -u Kedro. Kedro comes as an awesome CLI that we use in order to interact with our Kedro project. To create a new project, we type in Kedro new. Let's go ahead and just name this on example for now. We can go ahead and hit enter through all of these. We can open up that project. I'm going to use PyCharm. Kedro comes with a standard template for data pipeline projects. The most important folders for our exercise today are going to be the conf folder, the source folder, and the data folder. The conf folder holds configurations for your data pipeline. And I think that's something interesting because not many people realize or think about how they hard code configurations inside of their Jupyter notebooks. Often it's just simple parameters, but it also can include paths to data. This creates a barrier that prevents an individual from copying that Jupyter notebook and pasting it somewhere else, because that means you also have to paste a lot of these data paths exactly in the same way. Kedro abstracts this with its catalog, which we'll be investigating in just a little bit. The next folder on this list is the data folder. Now this is an obvious folder. It's where we keep some of the data. Kedro comes with a simple structure for designating your different tiers of data. We're going to be using this folder to store our data, but it is not required to store your data in this folder to use Kedro. Finally, the source folder is where all of the Kedro pipeline code is going to be sitting. As you can see here, the con example project name has been populated inside of the source folder, and this is where we're going to be putting a bunch of our pipes. Now, very quickly, I'm going to explain what I mean by data pipeline in Kedro. Now, if you'll take a moment to take a look at this graphic, here I have an example circles to triangles pipeline. This pipeline consists of 4 elements. The circles dataset is an example dataset which contains a bunch of circles. Right? You can consider it as a row of circles. Next, we have in here the center, the circles to triangle node transformation function. This is a transformation function that will turn the nodes into triangles. Next, we have a triangles dataset, and this captures the output of our circles to triangles node transformation function. Finally, the 4th element here is the pipeline itself. So the pipeline is what contains each of these elements, the 2 data sets on our transformation node, and is responsible for extracting data from the data set and then passing it into the circles to triangle node. Then it is also responsible for extracting the data from the circles to triangle node transformation function and then inputting it into the triangles data set. So these 4 elements are the basic elements of a Kedro pipeline. And these are going to be the elements that we'll be using today for our notebook conversion. Now that we have created a Kedro project and we have a copy of the notebook in question into the notebooks folder. Now making sure to source the virtual environment, I'm going to cd into our con example project and type in Kedro Jupyter Notebook. Kedro comes with a Jupyter Notebook integration. It makes it very easy to operate Kedro pipelines, as well as Jupyter Notebooks simultaneously. Navigating into our Notebooks folder, I'm going to go ahead and open this notebook. And we'll see here that there's actually a lot of libraries that we also need to install. Sourcing bin activate. We're going to do pip install -u Folium, Shapely, NumPy, Pandas, Matplotlib, requests. Next, we're going to install a Kedro library. Because of how many different ways you can connect to different data sources in Kedro, the Kedro team has split up the Kedro library into several distinct chunks. And one of those chunks is the Kedro Pandas chunk. This will allow us to read and write data using pandas. All right, let's go ahead with the very first portion here. There's a web API for the Global Biodiversity Information Facility that allows us to gather data for particular years. Let's go ahead and gather data and copy the URL. Very simply, I've just imported requests and I'm using the request.get function. So now that we have access to this object, I'm going to go ahead and just write it directly to disk into our data directory at 01 raw. And we're going to name this fielddata.json. Now that we have that initial data, let's go ahead and use Kedro to open it up. In order for Kedro to be aware of this data, we have to create a data abstraction. This is known as creating a data set inside of the catalog. So here I'm going to create a new key inside of this YAML file called field data, the type of which is going to be a json.json data set. And the file path is going to be the relative path to the 01 raw folder fielddata.json file. So now we've added this data set to the catalog. This means that Kedro has access to it. There's a few special objects that the Jupyter Notebook Kedro comes with. We have the context object, which just gives us the context of our project, and the catalog, which is the object that points to our Kedro catalog. If we do catalog.list, we're going to see nothing right now because we just added this. But using some Jupyter line magic, reload Kedro, we're going to reload all the Kedro configurations. And when we run catalog.list one more time, we're going to see field data appears. Calling catalog.load for the field data dataset, we'll find our JSON file. The reason why this data abstraction is important is because if you want to move your Jupyter Notebook, you no longer have to worry about making sure that all the file paths inside of that Jupyter Notebook are correct. You can simply use the Kedro catalog's data abstraction to refer to the file that you need. And then in the target machine or the remote machine, you just change the catalog.yaml file to point those data sets to the correct file paths. And you can start to imagine how portability can be achieved using Kedro in this way. Now, scrolling down a little bit more, we see that there's actually a cleaning function here. For every result that comes back in those pages, we're filtering those results to make sure that decimal latitude exists and turn it into a pandas data frame. This is going to be the first function that we create. It's going to be a cleaning function. Let's go ahead and name this clean raw field data. And now we have a data frame from the clean raw field data function. And here we see our new data frame with the clean JSON data. But what about Kedro? Where does Kedro come in now? Well, here's where it gets really interesting. Going into view, I want you to go to cell toolbar and I want you to allow tags. On this first cell with the function, I want you to type in node and add that as a tag. Then save. Now going back to our terminal, I want you to type in Kedro Jupyter. It has 3 commands. The first command, convert. What this is going to do is it's going to go through all of our notebooks that are inside of our notebook folder and convert any cells that we have tagged with node into a Kedro node. We're going to go ahead and type in Kedro Jupyter convert -- all. And you should see this converting notebook message. If you don't see this message, make sure that you've saved your changes with your tags in your notebook. Now what this has done is it's created a brand new Python file located inside of the nodes folder. Going back to PyCharm, here is our Python file created from our notebook. Let's go ahead and just rename this guy PNHM. Now that we've created a function to transform our JSON data into a pandas data frame, let's create a function that'll plot our pandas data frame. The function that I'm going to write is very simple. It's going to be called plot field data, and it's going to take in the field data frame, and it's going to return a pyplot figure. And in true pandas fashion, we've written a very long line. Let's go ahead and try this guy out. And here we get the plotted field data. Now let's go ahead and tag this as a node and then rerun our conversion function. And thankfully we're using PyCharm because here, as you can see, I've made a typo. Great. Now we have a field cleaner as well as a field plotter. Let's go ahead and create a brand new pipeline. Now by default, the pipelines are registered inside of the register pipelines function inside of the hooks.py in the root of your project module. In order to write our pipeline, it's actually very trivial. We're going to go ahead and take advantage of the current default pipeline that's available to us. And in here, we're going to add a node. And we're going to import it from Kedro pipeline. We're going to go ahead and use the clean raw field data function as our first argument. Now the next two arguments which are required by the node are the inputs and the outputs. Now notice here that we're taking advantage of the abstraction, and this field data is pointing to a JSON file. Finally, for outputs, we're actually going to create something arbitrary. Kedro is going to automatically turn that into an in-memory data set. Now the next node in the pipeline that we're going to create is going to be our plot field data function. And then the inputs is going to be the output of the previous one. And for the output field data plot, going back into our catalog YAML file, we're going to call this field data plot, the type of which is going to be the matplotlib writer. The file path is going to be data08 reporting field data.png. Now, with these two nodes, we've actually successfully created our entire Kedro pipeline. Opening up the terminal again, we're going to type in Kedro run. And here we have a very convenient log output showing us Kedro went through. And when we open up our data folder, opening up this PNG file will give us exactly the PNG that we saw inside of our Jupyter notebook. Thank you for joining me on this JupyterCon video. If you'd like to see more videos like this, make sure you check me out on YouTube at youtube.com/dataengineer1. And if you have any questions, feel free to hit me up on Twitter. I hope you guys learned something today, and I hope you guys have a wonderful rest of your Jupyter conference. Take care, and I'll see you guys next time. Bye-bye.